Hello, my name is Kevin Shepahang. I'm a PhD candidate at the University of Melbourne, and I'm going to present some explorations of memory for sentences that I carried out with the help of Professor Simon Dennis and Dr. Hyung-Woo Kim. If we have a sentence like John loves Mary, a naive approach to encoding it would be to assume three concept nodes, John, loves, and Mary, and then saying that there is an association formed between loves to John and loves to Mary. The problem here is that such an encoding leaves ambiguous whether it's John who loves Mary or Mary who loves John. We call this the role binding problem. Propositional accounts resolve the role binding problem by further assuming that the associative links are labeled with roles. Hence, the association between loves to John would be labeled with the agent role, and the association between loves to Mary would be labeled with the patient role. The problem with this approach is that the roles must be specified a priori. Dennis 2005 showed how it's possible to resolve the role binding problem without explicitly specifying role representations. In the syntagmatic paradigmatic, or SB, framework, two kinds of association are assumed. One kind, syntagmatic, forms between concepts that occur in the same context. For instance, John loves and Mary would be associated when seen in a sentence. The other kind of association, paradigmatic, forms between words that appear in the same serial position across sentences with the same neighboring words. For example, if Bob and Larry preceded the word loves in previously studied sentences, they would have a paradigmatic association. Later, John would form a paradigmatic association with Bob and Larry when encoding John loves Mary. Dennis showed that it suffices to know that John is Bob-like or Larry-like when resolving the role-binding problem. Now, given that paradigmatic associations can overcome the need for role representations and are therefore more parsimonious, how could we find evidence that people form such associations? One way is to show that recall of study items is more difficult when those items have paradigmatic associations with distractors relative to when they do not. Critically, a good test should place the SP account directly against the propositional account. We differentially manipulated two kinds of overlap between targets and distractors in a propositional overlap, absent versus present, by paradigmatic overlap, absent versus present, factorial design. In 3 experiments conducted through Amazon's Mechanical Turk, we presented the critical sentences in a narrative. Each subject read a single narrative with all 12 critical sentences scattered within. We later asked them about the 4 target sentences. More specifically, a given target sentence may have been something like Adam chugged his beer, which we would query in the passive voice by asking, who was the beer chugged by? The target responses were always moderate to high frequency proper names. The plot shows the probability of correctly answering a target question as a function of the presence or absence of propositional overlap in experiment 1. The line with the empty circles corresponds to the conditions with no paradigmatic overlap, and the line with the filled circles corresponds to the conditions with paradigmatic overlap. The error bars show the 95% credible interval. Whereas there was reliable evidence for interference in the presence of propositional overlap, there was only a marginal main effect of paradigmatic overlap. In the next experiment, we fixed a possible confound between distractor sentence position using another narrative and set of 12 critical sentences. In experiment 2, we obtained a reliable main effect of propositional interference, but this time absolutely no evidence for paradigmatic interference. To generalize to more narratives, we constructed 3 new ones and 3 new sets of critical sentences and randomized the names this time to each condition. Each subject was randomly given one of the 3 narratives. This time we obtained a propositional by paradigmatic interaction, such that in the absence of paradigmatic overlap, we get propositional interference, but when paradigmatic overlap is present, we have no propositional interference. Critically, we did not get evidence for paradigmatic interference. If we take the errors and bin them into those that are intralist, extralist, or blank, we can see if the errors corresponded to the propositionally overlapping lures or the paradigmatically overlapping lures. Here I'm defining an intralist error as an incorrect name that had occurred in another studied sentence. We are most interested here in these intralist errors. When propositional overlap is present, around 35% of the intralist errors corresponded to the name paired with the lure sentence. We are calling these propositional false memories, since the number is greater than we expect by chance. With 8 names, chance is around 12.5%. The pattern is consistent regardless of the presence of paradigmatic overlap. The following table shows some of the propositional false recalls. From left to right, the first column shows the cue, the second shows the answer the subject provided, and the third shows the correct answer. The column next to the correct column shows the target sentence that the participant studied, and next you can see the distractor sentence. So for instance, when the participant was asked, "Who was the grass raked by?" the subject responded, "Heather," instead of "Annie," because Heather raked the lawn was the propositionally overlapping lure that the subject also studied. Although one can argue that lawn and grass are almost interchangeable, the same cannot be said for confusions between bystander and protester, onion and watermelon, or rabbit and goat. In conclusion, our experiments provide reliable support for the presence of propositional interference, but no support for paradigmatic interference. Thank you.